Okay, so let's look at some more examples with the natural log. And remember, whenever possible, you should use the laws of logs to reduce the amount of work you have to do. Now, here's a function we've been asked to differentiate. Natural log of, inside the bracket, x e to the power 3x. And you may look at this and think, you know what, this looks like a composite function. I could maybe do natural log of u and let u equal x e to the power 3x. And then maybe use, okay, this is a product rule, isn't it? X times e to the power 3x. Use a product rule here and multiply it by 1 over u. And that would work. That would work. But if we use the laws of logs, we can do this fairly quickly rather than that lengthy method. Because what does laws of logs say then? When you multiply things like this here, x e to the power 3x, it's the same as adding them. So we could rewrite this as natural log of x plus natural log of e to the power 3x. And again, using the laws of logs, we can do something here. This 3x can come to the front, so we rewrite it again. And then we're left with natural log of x plus 3x times natural log of e. But what is the natural log of e? That's just 1. So what we're really left with is natural log of x plus 3x. So just basically, before we've differentiated anything, we've just rewritten it to this. And now we can differentiate it. It's addition of two functions, really. So we just differentiate each bit. So dy by dx, well, what's the differential of that? It's 1 over x plus, what's the differential of that? 3. There you go, 1 over x plus 3. Okay, let's do some further examples like this. Let's do something a bit more harder. Natural log, big fraction side, x cubed plus 5 x take away 3. Right, this looks fairly nasty. Okay, so natural log of all this, and you may be tempted to write ln of u and differentiate this thing in here using the quotient rule. It'll take you a long time, but just rewrite the whole thing, because this can be written as natural log of, remember, division means subtract, so x cubed subtract natural log of x squared plus 5 subtract natural log of x take away 3. If you're not sure why that is, you need to go back and revise some laws of logs, because you should be able to go from this straight to this. Okay, let's differentiate this. Oh, and one thing we could do here before we differentiate it, put the 3 to the front, so 3 log x minus log bracket x squared plus 5 log bracket x take away 3. Okay, now we can differentiate it. Well, what would this be? Okay, so remember, this is just a number multiplying natural log of x, so that's just 3 over x. Subtract, well, what would happen here? This is, okay, using the chain rule, but using the quick way of doing it, you'd have x squared plus 5 on the bottom, and then on top you'll have the derivative of this thing inside, would just be 2x. Subtract, same thing here. You'd have a x take away 3 on the bottom, and then on the top you would just have 1. So you get 3 over x take away 2x over x squared plus 5, take away 1 over x, take away 3. And that is the derivative of this function there. Alright, just one other thing, just be careful if it was something like this. Y equals the root of x times natural log of x cubed, like that, right? You may be tempted to do some laws of logs here, but this isn't really, there's nothing you could do here, because you don't want to put the root of x as the power of here. That would get really confusing. This is just the straight up product rule. Okay, so this would be your u, be root of x, and then this would be your v. And okay, well, let's just work it out. Okay, that's x to the power of a half, really. So du by dx would be a half x to the power of a minus a half, and then dv by dx would be x cubed on the top, and then what would we have? 3x squared on the top. Oh, something cancels out here, so x cubed with the that, so you just have with 3 over x. Okay, so then using the product rule, dy by dx would be u, which is root x, times the derivative of v, which is 3 over x, plus v, which is natural log of x cubed, times this here, this would be a half x to the power minus a half. Alright, just cleaning this up a little bit. Alright, that's x to the power of a half on top here. Alright, just clean this a bit over here. I'm going to multiply by 3 over x to the power 1, so subtract the powers a half, take a 1 as a minus a half. So that's just basically going to be 3 over root x. That's 3 over root x. Okay, what happens here? Well, first of all, I can bring, because of this log here, I can bring that 3 to the front and multiply by a half. So over 3 over 2. And then x to the power minus half is putting the root x on the bottom, and then you're left with just log of x there. So there you go. I could probably factor something out here, but I don't want to confuse matters too much. But there you go, dy by dx is this. So if you're confused by this bit here, is the 3's gone to the front, it's multiplied this half, so you got 3 over 2, and the x to the power minus a half I've just rewritten as x to the power of 1 over x to the power of a half, which is 1 over root x there. Okay, so there you go, that's the derivative of this function. So just be careful, sometimes you got to think as to which one you're going to use. Are you going to use the laws of logs, or product, or quotient rule, or what? Just be careful, use the right one. Okay.